All right, so my name is Clive. Morning, everyone. Um, I'm on ATC, working on Ukula, and my talk today will be um, on Git, that stupid content tracker. That's what it says when you try to get the main documents, right? All right, so a small history of origin. It was created by Linus Torvalds, and he did that because they had a fallout with Bitkeeper when he was developing the Linux kernel. And then he built Git with speed, integrity, and distributed workflows in mind. And what Git does is how it tracks the content. It doesn't track the diffs like every other VCS. It tracks it takes snapshots of your content state of the repo. And it's decentralized because you can get the repo anywhere and you can work offline. And then so when he was asked as to like why he decided to create Git, he said every other SCM system was too stupid or complicated. But then he went and said his content tracker is a stupid content tracker. I find that very interesting. And another interesting fact is he did this in 10 days. And how Git tracks your content is it creates a checksum of the content using the SHA-1 algorithm, but then they are moving to SHA-256 because, well, SHA-1 was exploited by um, the Google Shattered project. So what they did was they uh, they got two different PDFs to have the same SHA, but then those two different PDFs had different content in them. This is the reason why everyone is moving away from SHA-1 and they're moving to SHA-256. And Git is still on SHA-1 by default. And the way it ensures integrity is for every content that it serves to you, it first checks the integrity of the content and if the SHA is still the same, and it should be the same before it serves it to you. And then you can check your repo to see what algorithm your repo is using with the command that is here. And then before creating a Git repo, you have to initialize. You need to initialize it first, and the command to do that is here at the bottom. I will do this just now. So right now, I just initialized my Git repo, and I decided that object format, when it checksums my content, it should use the SHA-256 algorithm, right? And then to prove that that's the case, I'm gonna take this, and that's that right there. And then so how does Git actually track your content? So when you initialize it, it creates a .git directory, which is actually all you need. Um, and then in that Git directory, you have objects, which is where all your checksummed file contents are going to be saved in. And then you have the refs. This is where, because every reference after initializing the Git repo, reference meaning your tags or your branches or anything like that, they live in the refs/head. And every single one of them will point to a specific commit at any point in time whenever you want. And when you switch, what you're doing, you're literally just telling your branches to point to whatever commit that you want. And then the index, it's where you put your files. It's a staging area. So every single time you run git add, that's where git records what you're about to do. And then the config, when you install git, it comes with the global config file, which is where you put your global details, like your username and everything else. And then this one that comes with the .git directory is the repo specific one, which is where you'll find extensions for your algorithm and your your origin URLs and everything else. And then you have your hooks. So your hooks, anything that you want Git to perform before you push, before you commit, before you do anything, you can define those in the hooks, whether you're doing it locally or you're doing it on a server. Okay, so under the hood, when you git add, so with Git, you have like two types of commands. You have the normal commands that you use on a daily, which are your git add, git commits, and all that. And then you have they call those porcelain commands. And then you have the ones that do the heavy lifting, which are your they're called your damn it. It's porcelain and I forgot. I'll remember. But then it uses those commands to do the heavy lifting. So right now I have initialized this repo, and what I want to do, if I run git status, this is what I currently have in here. I can either git add or run the plumbing. Yes, damn it. They're called plumbing commands. So you can either do it that way. You can either do it with the porcelain commands, which is your git add, or you can do it with your plumbing commands, which are the commands that actually do the heavy lifting. And the porcelain commands actually use these plumbing commands in the background. So what I'm going to do is I'm going to copy this, and I'm going to do the same thing here. So with the hash object command, you can either tell it to write the object to the Git repository that's in your repo right now, your Git database that's in your repo right now, where it keeps everything that it tracks your content with. And let me just quit this, exit. And then if I open the directory, which you don't see, right? Excuse me, just give me a few seconds. So if you open the .git directory, it has all the directories and all these files that we just discussed earlier on. And if you look into this right here, right now, it has nothing. So if I'm now going to go and run the hash object command with the write, so that it writes to the storage, right? Then now, if we go back, there is a new directory that was created, right? And then how Git saves your objects is it takes the first two hexadecimal characters of your 40 character long SHA, and it creates a directory, and then it takes the file, which is the blob of the content that you just saved into that specific directory. So for every command that you run, every time you commit something, what you're basically doing is you're telling Git to hash the object and write it to the DB. Then we can move on with the slides. And then this is the SHA that was created. This is not a SHA-1, it's a SHA-256. So it's a bit longer than the normal 40-character long one, right? And then earlier on, we spoke about how it just takes snapshots and it doesn't do any diffs. So unlike any other version control systems like Subversion or Mercurial, Git doesn't store file changes. Instead, it stores complete snapshots of your project at every commit. So every time you commit, it takes a snapshot and then it saves it for you, right? And then each commit will point to a tree. And then every tree will point to a blob, which is your file contents, or it can point to a subdirectory, which is a subtree, right? And then if the file doesn't change, somebody said something very interesting once, and they said that Git will never store the same content twice. And that's what got me wondering. It's like, what do they mean by that? So if you have the same content in different directories, what it's going to do is, if it knows that it has that specific content already, it'll just point to that specific commit and move on with life. So it doesn't need to save that content again. And this is how it also ensures integrity. And it's fully distributed in a way that all you need is the directory, the .git directory itself. And what you do with it is you can recreate a working directory with it if you want. And the nice thing about it is you can have multiple people working on the same repo at the very same time offline. And when they decide that they want to merge their work together, all it has to do is just sync up all the snapshots in different times, and that's it. And then why Git wins in speed, integrity, and merging? So operations like your commits, your branch, your checkout, and log are local and lightning fast. So you don't need to communicate to a you don't need to communicate with a server to actually see your history or where you're at or where other people are when you want to, right? And integrity is it uses the hashing to ensure that the content that you saved stays like that, and it's still, and when it changes, it'll let you know. If it doesn't change, it will not store it. And the last point is Git auto verifies object integrity when reading from a disk. So after SHA-1 was exploited, what it does now is before it serves you content of every file, of every blob that it saves, it'll verify it and then give it show it back to you, right? And then with merging, Git merges entire snapshots, not just the files. So what it does is it'll take all the snapshots that you have and take all the snapshots that you want to merge in, and then find out which one came first and which one came after, and create that history for you so that you can continue working. Basically, that's what that means. And then this is possible because you have immutable objects, which are saved in your Git repo, and it has a self-contained object graph and references as commit pointers, and then it's a decentralized architecture. And then, as a recap, Git tracks your snapshots, not disks, and every commit is self-contained tree of objects. And .git repo directory, the .git directory holds the entire repo. And then you have your plumbing commands to do your checks whenever you need to. And you can use the plumbing commands when repos go messed up or you do something wrong and you just don't know how to go back, you can use the plumbing commands to actually investigate that. And the reason why I decided to look into Git was because I was tired of, cloning a repo multiple times. So what we're gonna do is I'm gonna show you a small demo of like why um of why you only need the .git repo, the .git directory for all that you need, right? So right now I use the update index, which is the same as your adding when you add your files or your files to the staging area. Right. So now if we run git status, you can see that all the files that I just that I had were added to my staging area, right? And then what I can do now is I can create a tree for all these, right? And after creating the tree, it'll give you back a SHA of the tree. So to see that, what we're gonna do is, sorry, I'm very nervous. If you want to see the insides of the actual SHA that get created for you, you can run the plumbing command cat file, and you give it either the P flag or the T flag. The T flag is to just see what type of a file it is. And we just said this is a tree. So I'll do that. And it says it's a tree, right? So what I can do is I can now commit the tree. I can commit the tree and actually like create an actual commit that I can later go to and that my master branch will be pointing to. Oh, I need to give it a commit message. Sorry. All right, so right now, I just created a commit. And after this, what we can do is, oh, if we check the status, you can tell that the files did not move from the staging area because I did not use git commit. I used the plumbing command to actually commit the tree. What you have to do now is you have to tell it that it needs to update the reference. Whatever the branch is pointing to, it needs to update to that specific commit. So I'm going to quickly do that. And I need this hash. So now I just told my master branch to point to the specific commit that we created. And if you run git status, my working directory is clean, right? So now, the reason why we only need this specific, the reason why we only need the .git directory, I'm going to demo that quickly and hopefully not take too much time. So I can actually clone the repo that I just created now locally, but then to make sure that I only get the .git directory, I'm going to make it a bad clone, and then I can point it to this directory and give it a name. So what we're going to do is I'm going to append the .git at the end so that we're going to host it on a server. But then hosting it on a server, you need to decide whether you want to use HTTPS or you want to use HTTP or you want to use SSH to access the repo, right? So if I put a .git at the end, it's just to say that I want to access it via SSH. So right now, I just cloned the repo that I created so that I can copy it and move it to an instance that I have somewhere on AWS, right? So what I'm gonna do is exactly that. Did I stop sharing? Let's first SSH into the instance. Then I created a directory called git to put everything, and we can ls. Oh, I don't see that. Sorry. Am I sharing the same thing? Okay, let me not waste any more time. So what I did was I SSH'd into my instance, and then in my instance, all I have is directories that I've been practicing with, right? So if you look in here, the directory that we just cloned now does not exist, right? So what I'm gonna do is I'm going to copy that whole directory and put it on the server. So currently what it's doing is moving the files or the directory to my server so that I can later clone it, or you can give me your SSH key and you can clone it and you can do whatever you want with it. Right, that's done. So I'm just gonna share everything so that when I move between these things. So now if we ls, we can see that that repo moved here, right? So now what I can do is I can clone this repo, and if you look into this repo, there is nothing other than the directories that Git uses just to track your content. And that's what we move to the server, right? So now what I'm going to do is I'm going to clone the very excuse me. Give me a minute. So I'm going to clone the repo that I just put on AWS now, and then into the talk directory. So now that it's done, we can open talk. And what Git did was it decompressed the files and then gave me the contents that I pushed up to track. So if you are paranoid and you don't like people looking at your repo and stuff on GitHub, you can just create your own server, put your own repos there, work on them, and move on with life. And that's all the time I have today. And thank you very much.